Welcome to the deep dive. Today we're going to dig into the Linux command line and shell scripting.
Yeah, we got this great resource, Linux command line and shell scripting techniques.pdf. Lots of good stuff in there.
Definitely. And our mission really is to pull out those key techniques, the insights that you can actually use right away without getting, totally overwhelmed.
And the authors, they really know their stuff. Jasmine Redzapagic, masters in computer engineering, tons of IT experience, now teaching open source.
Right. You can tell he's got that practical side. And Sergio Guidi Tobosa Pessoa, software engineer, over 30 years with Unix and Linux. Wow.
That's some serious experience.
Yeah.
So yeah, for everyone listening, we're aiming to extract that really actionable info, getting around the command line, the basics of scripting.
Exactly. We want to give you those aha moments, keep it practical.
Let's do it.
Okay, so first things first. How do we even get to the command line? Seems simple, maybe open a terminal.
Well, yeah, that's the common way on a desktop. Using a terminal emulator like GNEBI, terminal, console, something like that, inside your graphical environment. It's convenient.
Right. Best of both worlds. Kind of.
Kind of. But you might also just log in directly to a text interface, no graphics at all.
Like on older systems or servers, maybe.
Exactly. The book points out production servers often don't have a GUI. So knowing the pure command line is pretty crucial there.
Makes sense. So you need to be comfortable without the graphical bells and whistles sometimes.
Definitely. And if you're in the GUI but need to switch to text mode, the book mentions system tile.
Ah, right. System tile set default multi-user.target. That makes it boot into text mode every time, doesn't it?
Yeah, that changes the default for future boots.
Yeah.
It's a permanent setting, unless you change it back, of course.
Okay, but what if I just want to switch, like, right now, just for this session, without changing the default boot?
Good question. For that, you use system tile isolate multi-user.target.
Isolate.
Yeah, isolate just switches your current session to that target, the text mode in this case.
Yeah.
It doesn't change how it boots next time.
Got it. Set default for the long term, isolate for the immediate switch. Cool. Okay, so now we're there, staring at the command prompt.
The blinking cursor awaits.
And maybe you want to make it a bit more friendly or informative, customizing the bash shell. All right.
Exactly. And the main way is tweaking that PS1 variable.
PS1, right?
That variable controls the whole look of your prompt. You change it in your bash shark file.
Which is like your personal startup file for bash sessions?
Precisely. Every time you open a new interactive shell, bash reads .bash arc here, so you put your customizations there.
They show a simple example, like just changing it to my custom prompt.
Yeah, super basic. You just find the PS1 line in bash arch and change the text in the quotes.
But the cool part is adding dynamic stuff, isn't it?
Oh, yeah. You can use special codes, like for your username, H for the host name.
So you could have something like your name at your machine?
Exactly. And they show adding A for the 24-hour time, too. So you could have, like, you at HA showing user at host 14.30, puts useful info right there.
Okay, so you edit .bashic, save it, but it doesn't change immediately in your current terminal.
Correct. You need to tell the current shell to reread that file. You use the source command for that.
Ah, source.bashic.
Yep. Or you could just close the terminal and open a new one. That works too. But source applies it instantly to your current session.
Makes sense. The book also mentions other bash variables, PS2, hist file size, editor, PWD.
Right. Those control other bits. PS2 is the prompt for multi-line commands. Hist file size. Well, that's how much command history bash saves. Super useful.
And editor sets your default text editor. PWD is current directory.
Spot on. PWD just holds the path you're currently in. The big takeaway there, though, is caution. Don't name your own custom variables the same as these reserved ones. You could cause weird issues.
Good tip. Avoid clashes. So customizing isn't just looks, it's about making it work better for you.
Absolutely. Convenience, productivity, seeing the time or the host right there
Yeah.
as you typing other commands.
Okay, so shell's customized, now what? Doing actual work, right? Manipulating file.
Yeah, the basics.rm, cp, nv, ln, rm. Got to know these. Let's start with rm, removing things.
Right, rm deletes files, add the -r flag or -rf, and it deletes directories and everything inside them. And this is where you need to be careful.
Extremely careful.
Yeah, the book mentions users their rf username, which removes a user and their files. That rec is recursive deletion. It wisely says, think twice. There's usually no recycle bin on the command line. Gone means gone.
Yikes. Definitely measure twice, cut once with rm-rm.
Okay, CP is for copying.
Yep. CP, source destination.
Make it
Salt copy, simple enough.
and MV moving files.
Moving files or directories, yeah.
Yeah.
MV source destination. It's also how you rename files. If the destination is just a new file name in the same directory, you've effectively renamed it.
Okay. Now, lan.links. This gets a little trickier. Hard links versus soft links.
It does. Both let you access a file using different names, but they work differently. A hard link. Think of it as another actual name for the same file data on the disk.
Just like two doors into the exact same room.
Good analogy.
Yeah.
If you delete the original file name, the data is still there, accessible via the hard link. They share the same underlying inode, the same file size.
Okay. And soft links.
Soft links or symbolic links are different. They're
Yeah.
more like shortcuts. A soft link is a separate tiny file that just contains the path to the original file.
Ah, it's just pointing the way.
Exactly. So it has a different, smaller file size.
Yeah.
And crucially, if you delete the original file,
Soft link breaks.
yep, it's pointing to something that doesn't exist anymore.
Hmm.
The book uses that. Content.cfg example. Delete content.cfg, the hard link. Hardlink.cfg still works, but the softlink.cfg becomes useless.
Okay, that makes the difference really clear. Hard links are tied to the data, soft links to the path. Got it. Moving on, they introduced a tool called Screen.
Ah, Screen, a classic and incredibly useful.
I have to admit, I haven't used it a whole lot myself. What's the main idea?
It's a terminal multiplexer. Fancy term, but basically it lets you run multiple separate terminal sessions inside one single terminal window or connection.
Okay, like tabs, but maybe more powerful?
Kind of, yeah. You can switch between these virtual terminals. But the real magic, the killer feature, is detaching.
Detaching.
Yeah. You can start a process in a screen session, then detach from that session. The session and whatever's running inside it keeps going in the background, even if you close your main terminal window or, say, your network connection drops.
Whoa, seriously.
Seriously. Then later, you can log back in, reattach to that screen session, and everything is exactly as you left it, still running.
That sounds like a complete game changer for long tasks or remote server work, compilations, scripts.
Absolutely. If you manage servers remotely, especially over flaky connections, Screen, or its modern cousin Podmux, is indispensable. It saves so much frustration. The book mentions capabilities like copy, detach, fonts.
Yeah.
But persistence is the big win.
I can see that. Wow. Okay, definitely need to check that out. They give a link too. Good.
Yeah, worth digging into. Okay, so we've navigated, customized, managed files, even kept sessions alive. The next step is automation, making the shell work for us. Shell scripting.
Right. Building your own tools. They mention the Unix philosophy.
Exactly. Small, sharp tools that do one thing well, and you pipe them together. Shell scripting lets you bundle those commands into your own tool.
So how do you make a file into a runnable script?
First step, you need to give it execute permission. Chmod plus X, your script name.
Chammod plus X. Got it. Makes it runnable.
Then, inside the script file itself, usually the very first line is crucial.
That hashtag.binbash thing, the shebang.
That's the one.
Yeah.
Shebang. It tells the operating system which program, which interpreter should be used to run the commands in this file. Hashtag.binbash means use the bash shell.
And that's important because you could write scripts for other shells or Python or Perl.
Precisely. The shebang makes it clear. They contrast running it directly, like .your script, versus explicitly saying bash your script. The shebang makes the first way work reliably.
And the book also notes that Linux doesn't strictly require the .ish extension for shell scripts, right? It looks at the content, the shebang.
That's true. The .ish is a convention, a helpful one for humans, but Linux itself cares about the execute bit and that shebang line to know how to run it.
Okay, so to make this more concrete, they introduce an example script, a backup script.
Yeah, a simple backup script. It's a great way to see commands strung together and also to see potential problems.
A hands-on approach. So what's this first version of the script supposed to do?
It tries to do a few things in sequence. 1, create a directory inside opt backup named with the current date.
Okay, like opt backup mmddyyyyy.
Exactly. 2, copy everything from the root directory into that new backup folder.
All roots files. Okay.
3, send a quick email notification to the root user saying the backup's done.
Just a little confirmation message.
And 4, append today's date to a log file, rootdonebackups.lst, to keep a record.
Seems logical enough for a basic backup, but they immediately say this initial version has issues.
Oh yeah, big issues potentially. There's zero error checking. What if nkdir fails? What if kbig fails? The script just plows ahead.
It doesn't know if anything went wrong.
Right. It's not context aware either. Assumes opt backup exists and is writable. Assumes root is the right place to back up. It doesn't think about prerequisites. It's naive.
Just a raw sequence of commands. So what does the actual code look like?
It's pretty short. They show this bash, hashtag about bin bash, that mkdir opt backup date, plus backup, backup, date plus %%, mail as that backup was done. Root at localhost devnull, date plus present, Sean Pruner's fast at rooters backup side LSD.
I see the date command being used twice there inside backticks or dollar parentheses. That itself could maybe be improved later.
Good catch. Using a variable would be cleaner.
Yeah.
But yeah, it looks simple. But then they hit a snag right away with the mail command.
It wasn't installed.
Exactly, a common thing. The mail utility isn't always there by default. They had to run apt install mailoodles on their Debian-based system to even get that line to work.
Which perfectly illustrates why you should test each command individually first, right,
Yep.
before putting it in a script.
Absolutely. Test burnt-error, test CP, test mail, test the date command with redirection. Make sure each piece works before you assemble the whole thing.
Build it brick by brick. Okay. Now, managing how scripts interact, input and output. Standard input, standard output, standard error.
Right. The fundamental streams, standard input, sutandan, is where a command usually gets data from, often the keyboard.
Okay.
Standard output, stutout, file descriptor 1 is where normal results go, usually to the screen.
And standard error.suited.out, file descriptor 2.
That's a separate channel just for error messages or diagnostics.
Yeah.
It also usually goes to the screen, but it's distinct from sutout. This separation is really useful.
So you can handle errors differently from normal output. How do we redirect them, those angle brackets?
Yep, redirect suited out to a file. Careful, it overwrites the file if it exists.
Okay, overwrites.
Also redirects data out, but it appends to the file. Doesn't overwrite.
Appends, got it. And for errors.
Same idea, but you specify the file descriptor. To redirects data to a file, overwriting. To appends data to a file.
So 2 for errors, makes sense.
Right.
What about sending both steedout and steeder to the same file?
The easy way is ando. So command and output ander file. That captures everything in one place.
Handy shortcut. They briefly mentioned redirecting other file descriptors too, like 5 file name. Is that common?
Less common in basic scripts. It's for more advanced stuff where you might have multiple types of output you want to send to different places simultaneously. But often, managing that logic inside the script is clearer than juggling lots of file descriptors.
Right. Keep it simple where possible. Okay, last section they cover is shell script hygiene. Sounds important. Starting with comments.
Crucial. Good comments make scripts understandable later for you or someone else. In Bash, hashtag starts a single line comment. Everything after the hashtag on that line is ignored.
Just single line comments. No multi-line block like in some languages.
Not built in, no. But they show a neat trick for simulating multi-line comments using a here document.
That comment block thing, how does that work?
Delimiter starts a here document. Bash reads all the following lines until it sees delimiter on a line by itself. You're basically redirecting that block of text as input to nothing, effectively. So it acts like a comment block. Comment block is just a placeholder delimiter you choose.
Clever workaround. So what makes a good comment? What should we include?
Well, the basics: author, creation date. Versioning is good practice too, helps track changes.
Okay.
But the most important thing is explaining the why, not just the what. Especially for complex commands or tricky logic. Why did you choose this approach? What's the intention? Don't just restate the command in English. Explain the purpose.
Illuminate the thought process. That's great advice. Good comments save headaches down the line.
Absolutely.
Well, this has been a fantastic deep dive. We've covered a lot, from just getting into the shell, customizing it,
To essential commands like ARM, CP, MV, understanding links.
Yep. Uncovering the power of screen for session management.
And then getting our feet wet with shell scripting basics, making scripts executable, the shebang, and that backup example.
Yeah, the backup script was a great illustration. Showed how easy it is to string commands together, but also the importance of thinking about errors, prerequisites,
Yeah,
testing.
exactly. It's often an iterative process. Write, test, refine. Hopefully, this gave everyone a solid foundation and maybe a shortcut to grasping these Linux fundamentals.
Definitely. We really hope you listeners feel more equipped now.
And the best way to solidify this: get your hands dirty. Set up a test environment, a virtual machine maybe, and just experiment. Try these commands. Write simple scripts. Don't be afraid to break things. That's how you learn.
Couldn't agree more. So here's a thought to leave you with. Thinking about automation that PowerShell scripting gives you. What's one repetitive task in your workflow, something you do regularly that maybe, just maybe, you could start automating today with a simple script?
It's a powerful question. And remember, we've only scratched the surface here. There's so much more to explore in the Linux command line world. If you found this useful, let us know, and perhaps we can dive into more advanced topics next time.
Absolutely. Thanks so much for joining us on this deep dive.